here on the board, I've just summarized the results from what we did in the last video. Remember, we were calculating the value of an investment if we invested an initial $100 at 10% interest. This was not realistic. Compounded once a year. Not realistic. Okay, so what we determined was that at the end of the 1 year, we had our $100 times 1 plus 0.10. Multiplying by 1, we still had the $100. Multiplying by the 0.10, that was the interest that we earned that year. But then the second year, we were earning interest based on this amount. Okay, and so we ended up with 100 times 1 plus 0.10 squared. Because essentially, we were multiplying this quantity by 1 plus 0.10, because we had this plus we had 10% of this. At the end of the third year, we multiplied by 1 plus 0.10 again, because we had this plus 10% of this. So I can generalize that. If I have interest compounded annually, A, the amount that the investment is worth, is going to be P times 1 plus R to the T. The principal, that was our $100 here, that's the original investment, times 1 plus the interest rate expressed as a decimal, raised to the number of years that have passed. Okay, and we were able to sort of see where that came from. Okay, now, in general, it's not very common to have interest that's compounded just once a year. You might have interest compounded monthly. That would be 12 times a year. You might have interest compounded daily. That would be 365 times a year. So I'm going to now introduce N equal the number of times interest is compounded per year. Okay. And let's just, as an example, think of it as 12. Let's say that we were compounding things monthly. Okay? So over here, we'll say if it's monthly, N would equal 12. Okay. Now, the 10%, that's my annual interest rate. We don't suddenly, just because we're compounding interest every month, we don't suddenly start earning 10% every month. If we did, that would be fabulous, but it doesn't work that way. It would be dreadful for debt, fabulous for investment. Okay, so what we need to say then is that the monthly interest rate would be R over 12. Okay, we get 1/12 of that because we're basically just dividing the year into 12 parts. Okay, so if I'm compounding things N times, I'm going to have to replace this annual rate with the rate per compounding period. So R over N equals the interest rate per compounding period. Okay, so I'm going to have to adjust this. I'm also going to have to adjust this part of my formula, though, because at the end of 1 year, if I was compounding interest every month, I would have compounded it 12 times. Okay, so this N, that's the number of times we're compounding the interest every year. So N times T would equal the number of times we compound. I'm sorry, N would be the number of times we compound it per year. N times T would be the number of times we compounded the interest in T years. So when we were compounding once a year, the number of years corresponded to the number of times we had calculated the interest. Now, if we're going to be compounding it monthly, that would be 12T equals the number of times we compound the interest in T years. So I'm going to modify my formula by adjusting what I have here and here for this to become the interest rate per compounding period, and this to be not the amount of time, but the number of times we've calculated the interest. So what we'll have is that the value of the investment is the principal times 1 plus our interest rate per compounding period to the NT, raised to the number of times that we've compounded the interest per year. Okay. Or over that number of years. I'm sorry. N is the number of times we've compounded per year. N times T is the number of times we compounded in the T years that we're looking at. Okay. So this is the formula that's given in your book. The book, I don't believe, even gives you this formula. I just wanted to start with a simple case of let's just do it once a year and then modify it by adjusting these two things that were, this was an annual rate and this was the number of years, to rate per compounding period, number of times we've compounded. Okay. All right. So let's just practice using that. Okay. What I'd like to do actually is just compare with our example of $100 and 10%, even though it's not particularly realistic. Let's just compare what the value is worth after 5 years if we have simple interest, so value after 5 years. I want to do it with simple interest, compounded annually, and compounded monthly. Okay, so if we were doing the simple interest, it would have been the $100 plus the interest. Let me actually write out the basic formulas. The value of the investment would be the principal plus the interest. So that would be the principal plus the principal times the rate times the time. That was our formula for interest. So that would have been 100 plus 100 times 0.10 times 5. So that's going to be 100 plus 50. It would be worth $150. You'll notice I didn't bother to write the dollar sign while I was doing the work, but for my final answer, I do want to include that. Okay, now if it's compounded annually, that would be, the value would be the $100 times 1 plus 0.10 to the 5th. Now here, I am going to go ahead and say that's 1.1 to the 5th. Now, I'm going to pull out a calculator. Okay, you know you're not allowed calculators on exams and quizzes that are timed. Okay, this is a section when, as you're doing the homework, you're definitely going to want to use a calculator. Quite possibly on a take-home quiz, I will instruct you to use a calculator and just round to the nearest dollar. Okay, it is important that you get comfortable working with these formulas, and they basically do require the use of a calculator unless you want to spend a lot of time doing really tedious calculations. So it's not that I think calculators are evil and should never be used. I just don't want you to be overly reliant on them. This is definitely a time to use them. I will make sure that on exams and quizzes, if I'm asking you questions about interest, I will make them so that they're very easy to do by hand. You might have something like, what's it worth after a year? Or I might ask you about simple interest, or I might simply ask you, what's the formula? Or what would you plug into a calculator, but don't worry about doing it. Okay, so don't worry about the exams and quizzes, but do make sure that you're comfortable with this. That's really important because where we're going is to things where we're going to be able to solve for time. We're going to have problems where I want to know, when is my investment going to be worth this much money, because that's how much I need. I want to solve for T to figure out when it will be worth that much. That's the sort of thing we don't have the skills for yet, but we will. That's the sort of thing you will be able to do without a calculator. Okay. Now, you won't be able to simplify your answer the same way you would with a calculator, but you'll be able to express your answer using this thing called logs that we're about to talk about, without a calculator. So you need to be comfortable with this formula, and right now we're just using it to plug in and evaluate things. Okay, so let's see. 100 times 1.1 to the 5. I have $161.05. Now I rounded. It was 0.051, but I'm going to round that to the nearest cent. Okay, now if we're compounding monthly, let's just write this out. That's going to be 100 times 1 plus, now it's 0.10 over 12 is the monthly interest rate, to the 5 times 12. That's 60. 5 years is 60 months, so we would have calculated this 60 times. So 100 times 1 plus 0.10 over 12 to the 60th. Now, I'm going to go ahead and enter that into my calculator. Here, it wasn't as simple as 1 plus 0.1, so I didn't just do that in my head. Okay. What I'm going to do is I'm going to start with the 1 plus 0.1 divided by 12. And then I'm going to equal that out. So right now I've got 1.00833333333 going up forever. I'm not rounding at this point. That's still on my calculator. I've just calculated this thing. I'm going to now raise that to the 60th. Notice I'm just sort of doing order of operations. That was my parentheses. Now I'm going to raise that to the 60th. With my calculator, if I've got that number here and I just hit the exponent key, it's going to take that number and raise it to that power. So you may have to figure out how your calculator deals with these things. Okay. Equal that out, and then I'll multiply by 100, which I can actually kind of do in my head because that's just going to move things 2 decimals. And something went wrong, so I'm going to do it again. 1 plus 0.1 divided by 12 raised to the 60th. Okay. Sorry about that. I think I didn't hit the equal sign hard enough because I still had the other thing. Okay, and then times 100. Okay, so that's going to give me $164.53. And again, I've rounded to the nearest cent. Okay, so it did make a difference. I got an extra, almost $3.50 extra by compounding monthly instead of compounding yearly. And that was just 5 years with a very small initial investment of $100. Okay, so the more often you compound, the more your money is going to be worth. Okay. Now, as you enter this into a calculator, I sort of did it just one part at a time. I think that works very nicely, at least for my particular calculator. If you wanted to enter in this whole thing, you would need to have those parentheses. So you could have hit just 100, left parentheses, 1 plus 0.10 divided by 12, right parentheses, raised that to the 60th power. But you do need the parentheses if you're going to enter the whole thing at once. Okay.